Hello friends, I welcome you in lecture number 17 on double integrals. So let's start with this problem. Here we are asked to sketch the region of integration, reverse the order of integration, and then evaluate the given double integral. So in given integral, order of integration is first with respect to y and then with respect to x. So these limits are for y and these are the limits of variable x. So we are asked to evaluate this integral by reversing the order of integration. So here order of integration is first with respect to y and then with respect to x. So we have to change this order to dx dy. And as we know, for this order we are using vertical line from the region of integration. So to change the order of integration, we have to consider horizontal line passing through the region of integration. So for that we have to first sketch the region of integration. So we have written the limits of integration. Y is from 0 to y equal to 4 minus x square and x is from 0 to x equal to 2. So these are the three lines, and this y equal to 4 minus x square is nothing but parabola. So we first decide what is the vertex of this parabola. So for that we can rewrite this as y minus 4 equal to minus x square. So this again we can rewrite as x square equal to 4 minus y, and this again we can rewrite as square of x minus 0 equal to negative of y minus 4. So this is the parabola whose vertex is 0, 4. So which is a parabola with vertex order pair 0, 4, and due to negatives coefficient here it opens downwards, and it opens downwards. That means it will be like this. Here we will have vertex. Now we can decide the intersecting points of this parabola with other curves. Suppose we put y equal to 0 here, we will have 4 minus x square equal to 0. That will give us x equal to plus or minus 2. So these two will intersect at points plus or minus 2 comma 0. Similarly, if we put x equal to 0 here, y will be 4. So these two will intersect at order pair 0, 4. And if we put x equal to 2 in the parabola, we will have y equal to 0. So parabola will intersect line x equal to 2 at point 2 comma 4. So with this information we can sketch the region of integration. So first we sketch the coordinate axis. So this is x axis which we can represent by y equal to 0. Y axis is represented by x equal to 0, and maximum square on y axis required is 4. So suppose this distance is 2, so this is going to be 4. So this point is nothing but order pair 0, 4, and suppose this distance is 2. So this distance is 2, so this point is 2 0, and similarly this point is -2 0. So first we sketch the line x equal to 2 which will pass through these points. So x equal to 2 is the line parallel to y-axis passing through these points. So this is the line x equal to 2. And as we have seen, x equal to 2 intersects parabola at point 2, 4. So this point, just a minute, if we put x equal to 2 here, y is going to be 0. So it will intersect at 2, 0. For x equal to 2, if we put x equal to 2 here, y is going to be 0. So y equal to 4 minus x square will intersect x equal to 2 at order pair 2, 0. That means it will intersect line x equal to 2 at 2, 0. And it is passing through, parabola is passing through plus or minus 2, 0 and 0, 4. So these are the points from which our parabola will pass. 2, 0, minus 2, 0 and 0, 4. And we have seen that it opens downwards, so it will look like this. We can roughly sketch the parabola. So it will look like this, or we can modify this shape. Okay, it should look like parabola. So be careful that it does not look like straight line. Okay, so this is just a rough sketch, but we should take care that it should look like a parabola. So it will go in this direction and here in this direction. So this is the parabola y equal to 4 minus x square. So now we have sketched y equal to 0, x equal to 0, x equal to 2 and y equal to 4 minus x square. Now x is in between 0 and 2 and y is from 0 to 4 minus x square. So we are interested in the portion which is between x equal to 0 and x equal to 2. So we are interested in this part which is between x equal to 0 and x equal to 2 and between y equal to 0 and y equal to 4 minus x square. So our region of integration is a region which is bounded by all these curves. So this is the region of integration. Upper boundary is parabola, lower boundary is x-axis, that is y equal to 0. Right boundary is x equal to 2 and left boundary is x equal to 0. Now here to change the order of integration we have to consider horizontal line, because in given integral order of integration is dy dx. So to obtain this order dx dy we must consider horizontal line passing through the region of integration. So suppose we consider this horizontal line passing through the region. We can consider horizontal line in any part of the region. Suppose we consider on this in this part of the region. So now on this horizontal line y becomes constant and x is changing, and we are interested in the value of x at these 2 points. So this point is on y-axis, so here value of x is 0. So here we write that line enters at x equal to 0. This point is on the parabola y equal to 4 minus x square. So from this we will find out value of x. X square is 4 minus y. So x is plus or minus y. But here x is positive, so we will consider positive value of x, and here we write leaves at x equal to square root of 4 minus y. And for limits of y, we have to consider lowermost points of the region and uppermost points of the region. So the lowermost points of the region are on x-axis, and at all these points value of y is 0. And this is the uppermost point of the region. At this point value of y is 4. So y is from 0 to 4 and x is from 0 to x equal to square root of 4 minus y. Okay, so now we write that the region of integration is as shown in following figure, and to change the order of integration we consider horizontal line passing through the region. So to change the order of integration, we have considered horizontal line passing through region. So as we have discussed, the new limits of integration are x is from 0 to square root of 4 minus y, x equal to 0 to x equal to square root of 4 minus y, and y is from 0 to y equal to 4. So therefore now the order of integration is reversed. Order of integration is first with respect to x and then with respect to y. So therefore we write down the given double integral, and we have to write the integral which is equivalent to given integral after changing the order of integration. So this was the given double integral, and after changing the order of integration our function is x e raised to 2y over 4 minus y. Now we have reversed the order of integration, so now instead of dy dx we write dx dy, and limits of x are from 0 to square root of 4 minus y, and y is from 0 to 4. So this is the double integral obtained after changing the order of integration from dy dx to dx dy. Now to evaluate this double integral, first we find out value of inner integral. Here integral is with respect to x, so we will consider y as constant. Now because y is constant, e raised to 2y upon 4 minus y is constant, and integral of x is x square by 2. So here we have x square e raised to 2y and 2 times 4 minus y. E raised to 2y divided by 4 minus y is constant, and integral of x is x square by 2. Limits of x are from 0 to square root of 4 minus y, and then we will integrate with respect to y. So first we put x equal to square root of 4 minus y. So we can see if we take square root of 4 minus y, we have x square equal to 4 minus y, and this is as it is. And for lower limit we will obtain 0 because x is in the product. So now this 4 minus y will cancel out, and 1 by 2 is constant that we can take outside, and we are left with integral of e raised to 2y from 0 to 4. Now integral of e raised to 2y is e raised to 2y divided by 2. Limits are from 0 to 4. So first we put y equal to 4, so it is e raised to 4 minus y equal to 0, that is e raised to 0, which is 1 divided by 2. So finally we obtain this is 2 into 4, that is 8. So finally we obtain that value of double integral is e raised to 8 minus 1 divided by 4. So this is very interesting example. We have this parabola, and region of integration is bounded by this parabola between x equal to 0 and 2, and we are able to change the order of integration and then evaluate the value of given double integral. So this is all about today's session. Thanks for watching.